There are 5 languages that are all a part of the IEC, or International Electrotechnical Commission, Section 61131-3 standard. This IEC standard allows some ground rules that standardize PLCs in their languages. Let's take a deeper look into all these PLC programming languages. Before we get started on today's video, if you love our videos, be sure to click the like button below. Then make sure to click subscribe and the little bell to receive notifications of new RealParse videos. This way, you never miss another one. The 5 PLC programming languages are Ladder Diagram, or LD, Sequential Function Charts, or SFC, Function Block Diagram, or FBD, Structured Text, or ST, and Instruction List, or IL. Let's show you a little bit about each of these. I will start with Ladder Diagram, which is a graphical type of PLC programming language. Ladder Diagram was originally modeled from relay logic, which used physical devices, such as switches and mechanical relays, to control processes. Ladder Diagram utilizes internal logic to replace all except the physical devices that need an electrical signal to activate them. Ladder Diagram is built in the form of horizontal rungs with 2 vertical rails that represent the electrical connection on relay logic schematics. You can program all the necessary input conditions to affect the output conditions, whether logical or physical. The main advantages of the Ladder Diagram language are that the rungs allow it to be organized and easy to follow. It also lets you document comments that are readily visible, and it supports online editing very successfully. The main disadvantage is that there are some instructions that are not available, which might make it more difficult for programming, such as motion or batching. The next PLC programming language that I will talk to you about is the Sequential Function Charts, which uses a graphical type of programming. If you have any experience with flowcharts, then this PLC programming language will feel familiar to you. In Sequential Function Charts, you use steps and transitions to achieve your end results. Steps act as a major function in your program. These steps house the actions that occur when you program them to happen. This decision can be based on timing, a certain phase of the process, or a physical state of the equipment. Transitions are the instructions that you use to move from one step to another step by setting conditions of true or false. Unlike traditional flowcharts, the sequential function charts can have multiple paths. You can use branches to initiate multiple steps at one time. A couple of the advantages of sequential function charts are: processes can be broken into major steps that can make it faster and easier troubleshooting. You have direct access in the logic to see where a piece of equipment faulted. It can be faster to design and write the logic due to the ability to use repeated executions of individual pieces of logic. Even when you consider the advantages of the sequential function charts, this PLC programming language does not always fit every application. Now, we are on to our third PLC programming language, the Function Block Diagram, which is also a graphical type of language. The function block diagram describes a function between inputs and outputs that are connected in blocks by connection lines. Function blocks were originally developed to create a system that you could set up many of the common, repeatable tasks such as counters, timers, PID loops, etc. You program the blocks onto sheets, and then the PLC constantly scans the sheets in numerical order or is determined by connections which you program between the blocks. The code can get disorganized using this PLC programming language because you can place the function blocks anywhere on the sheet. This can also make it more difficult to troubleshoot. The function block diagram does work well with motion controls, and the visual method is easier for some users. The biggest advantage of function block diagram is that you can take many lines of programming and put it into one or several function blocks. Our fourth PLC programming language that I'm going to review is the structured text. This language is a textual-based language. Structured text is a high-level language that is like BASIC, Pascal, and C. It is a very powerful tool that can execute complex tasks utilizing algorithms and mathematical functions along with repetitive tasks. The code uses statements that are separated by semicolons, and then either inputs, outputs, or variables are changed by these statements. You must write out each line of code, and it uses functions such as for, while, if, else, else if, and case. If you have experience with BASIC or C languages, this PLC programming language will come easier than some of the other languages. Some of the advantages of structured text are that it is very organized and good at computing large mathematical calculations. It will also enable you to cover some instructions that are not available in some other languages, like the ladder diagram. The disadvantages are that the syntax can be difficult, making it hard to debug, and it's difficult to edit online. I will now show you the fifth and final PLC programming language, which is instruction list. The instruction list is also a textual-based language. The instruction list language resembles assembly language. When you use this PLC programming language, you will use mnemonic codes such as LD or load, and, or, etc. The instruction list contains instructions, with each instruction on a new line with any comments you might want to annotate at the end of each line. This instruction list language is valuable for applications that need code that is compact and time-critical. The main disadvantages of this PLC programming language are that there are few structuring possibilities, with the goto command being one of them. There can also be many errors that are more difficult to deal with in comparison to many of the other languages that I've previously reviewed. So, have you decided which PLC programming language you consider to be the most popular? After reading many reviews and opinions, and with my own experiences, the ladder diagram language is by far the most popular. The main reason for this is that the ladder diagram language naturally followed the technology advancement from a physical relay logic to a digital and logical one. This allowed the engineers and skilled workers to follow and troubleshoot and make that transition. In summary, there's certainly a place for all the PLC programming languages that I've discussed with you today. Background, experience, and the application you are working with are really going to be the key to which PLC programming language you choose. Want to learn PLC programming in an easy-to-understand format and take your career to the next level? Head on over to realpars.com.